Okay, so we have just gotten done with the table where you were counting some protons, giving some symbols, writing down some electrons lost or gained, and getting a charge. So we're going to add to that a little bit today, but we are going to talk about isotopes and then give you guys the last bit of information you need. So first of all, we're going to talk about is mass number. So mass number is how much the atom is going to weigh. So the two pieces of information that we're going to count are going to be the protons and the neutrons. Now, if you remember, I said that the electrons have mass, but it was really small. So we're just going to focus on what's in the nucleus, protons and the neutrons. So mass number, and you got a couple of blanks here, is going to be number of protons and number of neutrons in the nucleus. So you can write down mass number would be protons and neutrons, or protons plus neutrons, however you want to look at that. We're going to usually measure that in grams. Atomic mass units are used, but not specifically a lot in this class. Do want to point out something on your periodic table. So we'll go ahead to copper right here. Look at copper. It's got an atomic number of 29. That's its protons. But then it's got this 63.55 at the bottom. Okay. The 63.55 is called average atomic mass. That is not mass number. What that is that there's different kinds of copper. Some weigh 64, some weigh 63, some probably weigh 62. There's different types, and they have a slight variation, which is they have more or less neutrons. But I just want to stress, again, that what we're talking about today is not the 63.55. We're going to use that number later, but that's not mass number. Mass number is something that's a whole number, not a decimal. You can't just look it up. You usually have to do a little bit of addition or subtraction. Okay, so an isotope's another fancy word. So we had the word atom. That's going to be an element without a charge. Then we have the ion. So those are going to be charged particles. So they have plus ones or minus twos or whatever. And now this new word isotope. So what an isotope is, it's the same element. You'll notice I've got carbon and carbon and carbon. So an isotope is the same element, but what it is different about it, why it has the word isotope, is that each version of it has a slightly different weight. So you'll see this carbon only weighs 12. This carbon weighs 13. And this carbon weighs 14. The only difference is their neutrons. So this carbon is heavier, more neutrons. This carbon is lighter, it has less neutrons. And so we have more or less neutrons, and so that's going to create the isotopes, right? So when we go down here and we take a look at this definition, I've got this right here. It just says right there, isotopes have the same atomic number. They're all carbon. They all have a 6, all right? But they all are going to have a different mass number, right? So the graphic below, we've got 3 items. Each of those items is an isotope, and they want to know what isotope is this. So what isotope do we have down here? So we got 3 things. Which isotope do we have? Okay, so this is really easy. To figure out what isotope you have, you just look at the protons. 1 proton, 1 proton, 1 proton. Notice they all have the same number of protons. The only thing different is those neutrons. So what we're going to do is we're going to go over to our periodic table. And we're going to look right here. There's hydrogen. See, it has the number 1 proton. So we go back to our 1 proton, 1 proton, 1 proton. All 3 of those are the same element. They're just isotopes. They're going to be isotopes of hydrogen. So you want to write that in over here somewhere, isotopes of hydrogen. So we will continue to work with the isotopes. I've got a whole exercise you guys are going to do later on the isotopes. Okay, so we're going to dive into this last bit, which is going to explain how to write out what we're going to call a nuclear or an atomic notation. And so if you look right here, This is a nuclear symbol, right? So we've got magnesium, and it's got a +2 and a 24 and a 12. Like, we got to figure out what the heck that stuff is and how to create that. This is one of the things you got to be able to do, create those for me. And here's just another one. This is hydrogen, doesn't have a charge. So we're going to kind of go over that, and it's really, really easy. And then we're going to do an example. So let's take a look at the magnesium. So the number on the left right here, in the left corner, that's how much it weighs, which we just learned is called mass number. So that's protons plus neutrons, right? Bottom left number is magnesium's atomic number. So that's just looking up on the periodic table. And then, of course, there's the charge. So we talked about how to figure out charge previously, but let's go to the periodic table real quick. Here we go, magnesium right there. Look at the top number, 12. Well, over here, when we use this particular notation, that number goes on the bottom left. Now, when we look at this, we're like, okay, that 24, where'd that come from? Well, that 24 is the bottom number, 12, plus the neutrons. So we would be able to figure out that this particular magnesium had 12 protons and 12 neutrons, because 12 plus 12 is 24. So if you look over the hydrogen, it has 1 proton, and then would have 2 neutrons to get to 3. Now we're going to work through the examples on that, right? Now I want to point out, once again, let's go to magnesium. 24.31. That is not, you're not using that at all in the nuclear notation, because that is average atomic mass, which is a blend or an average of all the types of magnesium, all its isotopes. And there's some that weigh 24, some that weigh 23, some that weigh 25. And we are not going to be using that number today, okay? So I'm going to stop the video here because I need the 15 minutes to go over the next example. And you can go back over this. But once again, we're going to go through the next example, and you're going to want to create that chart on a piece of notebook paper. And you'll kind of see that I'm doing the same thing when I'm working through the example with you guys, okay?